Alright, so let's take a look at number 10. It says you burn 10 calories a minute. How many would you burn in 5 minutes? Now, it seems pretty straightforward, right? So 10 calories a minute, 5 minutes, 10 times 5 would be 50. And that is true. The answer is 50. But really what this question's after is more of, can you represent what's happening? Can you set it up as a table? Can you make a graph? And can you make an equation? So the math is easy. We just got to make sure we know how to set it up. Well, so one thing would be is that let's look at the table first. So time in minutes and calories. And the number of calories you burn depends upon how long you're working out. So that's why this would be our dependent variable, our y, and time would be our independent variable, x. So, I don't know, let's just make a table. So in 1 minute, you'd burn 10 calories. 2 minutes, you'd burn 20. 3 minutes, you'd burn 30. 4 would be 40. And as we already said, 5 would be 50. And what we want to be able to do is that we want to be able to then graph that. So, again, 10 calories, 20 calories, 30 calories, 40 calories, and 50 calories. As is the first problem, we said that this represents a linear relationship. And we can see that for two reasons. One, because when we graph it, we see that it makes a straight line. But two is because if we look at how the table is changing, so we're looking at the rate of change. And what this is being, first you might think that that's being added by 10, and that's exactly what's happening there. Each one of them would be added by 10. So you know that it's linear because the rate of change is the same. So up by 10, up by 10, up by 10, it's constant. The reason why this is a straight line is because it's going up at a constant rate. So what I'm looking for, so again, go back to our little machine that we mentioned in the first problem. A 1 goes in, and then a 10 comes out, and we're trying to figure out what's happening inside this machine that would turn a 1 into a 10 or turn a 2 into a 20. Well, hopefully you could kind of see, go back to what we said in the very beginning, right? 10 times 5. So it's just 10 times the number of minutes. So each one of those is being multiplied by 10. So our answer there would be y equals 10x. And what we mentioned in that first problem is that we said that with a linear relationship, it could be modeled or set up by looking at this. That the number that x is being multiplied by, that is your rate of change. And so our rate of change, for instance, in this one is 10, because it's going up by 10 each time. And then what we said is that this last number represents the value of y when x equals 0. Or another way to kind of think of it is that so there's this pattern, right? And so we're saying where did the pattern kind of start? Well, if you counted backwards to when x was equal to 0, then the y would also be equal to 0. Like if I counted back to that point right there. So that's why it's plus. That's why it's not plus any other number, is because the y-intercept there, the value of x, the value of y when x is equal to 0 is 0. So that's where we just would leave it there. Y equals 10x. All right. So take a moment, try 10.2 and 10.3. All right. So let's take a look at 10.2 in the middle. So 10.2 in the middle should have got y equals 70x. 4 hours, 70 miles an hour, 4 times 70 would give you 280. And then $8 an hour, 6-hour shift, 8 times 6 would give you 48. And so it's 8 right per every hour. All right, so that finishes up with number 10.